In this video we'll talk about specifically logarithmic functions. This is the important part of what a logarithm is, how a logarithm is defined, and that is that if you have log base a of x equals y, that means a to the power y is equal to x. Okay, so again, this is an inverse of an exponential function where we have a function that's considered to be one-to-one, therefore we get a logarithmic function as the inverse. Three main laws of logarithms. I'll kind of work backwards here. If you are adding two logs together that have the same base, you can combine them as a single log and do a product of those individual pieces on the inside. If you are subtracting, it's the same thing, but you do division on the inside. And then if you have a constant multiplied out front, you can bring that into the log as an exponent. Okay, those are the three main laws of logarithms. So if I were to use the laws of logarithms to solve one, what I would want to do, first of all, you could try to solve them individually, but remember what this is saying is, this first part is saying, well, what is the exponent that I would put on 2 in order to give me 80? And 80 is not a power of 2. And then the same thing with 5. What exponent would I put on 2 to get 5? I can't think of an exponent off the top of my head that would make that happen. So because they are both log base 2, I can use the property of division here because it's subtraction, and I can do 80 divided by 5 on the inside. So that would give me log base 2 of 16. And so now I'm asking myself 2 to what power is equal to 16, and the answer to that is 4. Natural log. Remember, natural log is simply a log base e. And so instead of writing log base e, you'll just see ln. Here are some examples. If we have the natural log of x is equal to 5, and I want to know what x is, oftentimes it's easy to think of that base being e, and then rewriting this as an exponential would say that e to the power 5 is equal to x. And I could evaluate e to the 5th, it's going to give me some decimal, or I could just say e to the 5th, it's more exact. So x is going to be e to the power 5. And then whenever we're solving an exponential equation, we often need to use logarithms to help us do that. So just think, anytime that your variable is in the exponent, in order to get that exponent to come down so that we can solve for x, we're going to need to use a log. And if the base is e, then natural log is the log that you would choose. So what you do is you simply take the natural log of both sides, and then on this side I just end up with the exponent. The natural log of e cancels, the exponent comes down, and therefore I just have 5 minus 3x. And on the right side I have the natural log of 10. Okay, then we want to solve for x. So I'm going to subtract 5. That does not become the natural log of 5. So I have negative 3x is equal to the natural log of 10 minus 5. And then I can divide by negative 3. And again, I could plug this into the calculator, but I just get x equals the natural log of 10 minus 5, all of that divided by negative 3. The last thing is a change of base formula. And the way the change of base formula works is I can pick whatever base I want for this, so I don't even have to use natural log. Another way to write this would be I could say log base b of x divided by log base b of a. And you can use change of base formula to help you if you don't know what exponent you would put on a to get x. Okay, so let's say that like a and x are both powers of 2, for example. Just give you a quick example of this. Let's say I want to do log base 8 of 32. And I have no idea. The question then is 8 to what power equals 32? It's not 4. 8 times 4 is 32. But I want to know what exponent I would take 8 to get 32. And I don't know that. But what I can do is, because 8 and 32 are both powers of 2, I can rewrite this as log base 2 of 32 divided by log base 2 of 8. And then I can evaluate each one of those separately. So on top, 2 to what power gives me 32? That is 5. And on bottom, 2 to what power gives me 8? That is 3. And so the answer is 5/3, which says if I took 8 to the 5/3 power, I would get 32. Now, if you really understand what a rational exponent is, maybe you could figure this out without having to do this change of base. But you're kind of doing that in your head without really thinking about it. Okay, so it is a valuable formula to know in order to change your base so that you can evaluate each part whenever you can't evaluate the thing as a whole.